In the last videotape, we studied trig functions of some basic first quadrant angles. It would also be helpful to know the trig functions of some second, third, and fourth quadrant angles as well. Now, if you've ever looked at a table of trig functions found in most elementary mathematics books, you might notice that they're only given for angles between 0 and 90 degrees, for first quadrant angles. And there's a good reason for that. It's a very simple problem to change the problem of finding the trig function of, say, a second, third, or fourth quadrant angle into one of finding the same trig function of a corresponding acute angle, which we call the reference angle. Okay, let me discuss how we find these reference angles. Okay, let's say we're working with an angle theta. If the angle theta is in the first quadrant, second quadrant, third quadrant, we're going to consider these possibilities, fourth quadrant. Okay. If the angle theta is in one of these quadrants, we're going to discuss how to find the acute reference angle that we're going to be using. Then the acute reference angle to use is, okay. Now, I want to make sure everybody understands what I'm talking about when I say a first quadrant, second quadrant angle, and so on. A first quadrant angle would be one between 0 and 90 degrees. So theta would lie someplace between 0 and 90 degrees. A second quadrant angle, an angle whose terminal side was in the second quadrant, would lie someplace between 90 degrees and 180 degrees. Third quadrant angle would run between 180 degrees and 270 degrees, and a fourth quadrant angle between 270 degrees and 360 degrees. Now, I'm going to concentrate on degree measure in this videotape, although it's a very simple matter to change any of these to radian measure. You would just multiply by pi over 180 degrees. For example, 90 degrees corresponds to an angle whose radian measure is pi over 2 radians. Okay, now, let's draw a picture. If the angle theta is in the first quadrant, that is between 0 and 90 degrees, and you're interested in finding trig functions, say sine, of this angle theta, if you were using a table of trig functions, you would be able to find it directly from the table because theta itself is an acute angle. Okay, so you would just use theta. If the angle theta were between 0 and 90 degrees, you would use theta. You would look that up in the table directly. If, however, you're talking about a second quadrant angle, one between 90 and 180 degrees, let me draw a picture for you. Here is a typical second quadrant angle, one whose terminal side, in standard position, its vertex is at the origin, its initial side goes along the positive x-axis, its terminal side is somewhere in the second quadrant. Okay, here is a second quadrant angle, theta. Okay, the acute reference angle to use in this case is 180 degrees minus theta. In each case, what we're going to be doing is trying to find the smallest positive angle between the terminal side of theta and the x-axis. Okay, so if you're in the second quadrant, obviously the terminal side is closer to the negative x-axis than it is to the positive x-axis. We are looking for the smallest positive angle between the x-axis, any part of it, okay, and the terminal side. Clearly, the terminal side here is closer to the negative x-axis than it is to the positive x-axis. So we would like to use as our acute reference angle, okay, the angle between here and here, which is 180 degrees, which is all the way over here, minus theta. This is the angle that we're using for our reference angle. Okay, now if we were in the third quadrant, let's say we have a third quadrant angle, looks something like this. Let's say this is theta. Okay, its terminal side is in the third quadrant. Once again, we are interested in the smallest positive angle between the terminal side of theta and the x-axis. Once again, we are closer to the negative x-axis than we are to the positive x-axis. So we are interested in this angle being our acute reference angle. We want to know, say, how far off the horizontal is this terminal side. Now, if theta is from here all the way to here, and 180 degrees measures from here to here, we are looking for theta minus 180 degrees. That would be the acute reference angle. Theta would be all the way to here. Take away 180 degrees would give us this acute angle, which is our reference angle in this case. Finally, in the fourth quadrant, okay, let me draw a typical fourth quadrant angle. Okay, it's going all the way around like this. This is the terminal side of the angle, measured in a counterclockwise direction. Okay, we are interested in the smallest positive angle between the terminal side here and the x-axis. Now here we are closer to the positive x-axis than we are to the negative x-axis. So we're interested in this angle in here being our acute reference angle. If a complete rotation here would be 360 degrees, and this represents theta from here to here, then 360 degrees less theta would give us this angle in here, and that would be our acute reference angle. In each case, okay, for any angle theta, the acute reference angle to use is the smallest positive angle between the x-axis, any part of the x-axis, and the terminal side of theta. For any angle theta, it can be of any size. The acute reference angle to use would be the smallest positive angle between the x-axis and the terminal side of theta. Okay, if the angle theta is in the first quadrant, then clearly it is closest to the positive x-axis rather than the negative x-axis, and theta itself is the acute reference angle to use. In all other cases, we somehow have to adjust to get an acute angle. And in each case, we're sort of measuring the distance off the horizontal, the amount of degrees we are off the horizontal, the nearest part of the x-axis, okay, for the horizontal. In the second quadrant, we're interested in this being our reference angle. Okay, this angle in here. So it's 180 degrees minus theta. In the third quadrant, we're using this as our reference angle. This is how far we're off the horizontal. And in the fourth quadrant, we're using this, 360 degrees minus theta. Okay, now the problem of finding the trig function of an angle of any size can be reduced to finding the same named trig function of the corresponding acute reference angle. The only catch is that you have to figure out if there should be a plus or a minus sign prefixed to the trig function. Okay, and let's discuss that now. In a few moments, we'll be working out examples, and this will all make a lot of sense. It can be proven that the trig function of a second, third, or fourth quadrant angle is equal to plus or minus the same trig function of the corresponding acute reference angle, where the plus or minus sign, so in other words, it's really going to be only a plus or a minus sign, and we have to figure out which one applies. Okay? The plus or minus sign is determined by the quadrant in which the original angle lies and the trig function in question. According to the following. Okay, I'll explain in a moment how we figure out the plus or minus sign. First of all, we're faced with the problem of finding a trig function of a second, third, or fourth quadrant angle. If it was just a first quadrant angle, we could merely look it up in a table of values, or we would know it if it was a basic angle. Second, third, and fourth quadrant angles are not explicitly given in tables. It's assumed that you would be able to transform the problem in the following way. It will be equal to, if you have, say, any trig function of a second, third, or fourth quadrant angle, will be plus or minus the same named trig function of the corresponding acute reference angle. This is how you find the reference angles. You get the reference angle, which will be between 0 and 90 degrees. You take the same trig function of that reference angle with a plus or a minus sign before it. Now, the plus or minus sign is determined by the quadrant in which the original angle lies and the trig function in question, according to the diagram that I'm going to work out for you over here. Okay, now to determine the appropriate sign. Remember, it's going to be plus or minus. We have to go back to the original definitions that I gave you for the trig functions. If you will remember, to define the trig functions, we took an angle in standard position. Let's say that it's a first quadrant angle. We picked any point on the terminal side of this angle. We called it, say, P. Its coordinates were x, comma, y. The distance of point P from the origin we denoted by R. This is, say, an angle theta. Then, the sine of theta was defined to be the y-coordinate of this point over r. The cosine of theta was the x-coordinate of the point over r. And the tangent of theta was y over x, where we assumed that x was not 0. And we also had three other trig functions which were reciprocals of these. Cosecant theta was defined to be r over y. For our purposes, it will be enough to say cosecant theta is 1 over sine theta, assuming sine theta is not 0. Secant theta is 1 over cosine theta. Cotangent theta is 1 over tangent theta. Once we know sine theta, it's very simple to get cosecant. It's just a reciprocal. Cosine theta, the reciprocal of that would be secant theta. The reciprocal of tangent theta is cotangent theta, assuming in all cases that we have a fraction that the denominator is not 0. Now, we're interested in the sign of trig functions. Okay. We have quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay, in the first quadrant, point P, which is on the terminal side of this angle, must have a positive x coordinate, a positive y coordinate, and of course r must be positive because it represents a distance. Since x and y and r are all positive, sine theta is positive, cosine theta is positive, tangent theta is positive, and the reciprocals of these are positive. So, in the first quadrant, all trig functions are positive. For first quadrant angles, those between 0 and 90 degrees, all trig functions are positive. Since no matter where this point, where the terminal side is, it's somewhere in the first quadrant, the point P on the terminal side must have positive x and y coordinates, or it wouldn't be in the first quadrant. R is positive, and therefore all the trig functions are positive. In the other quadrants, some are positive and some are not. Let's look. In the second quadrant, let's say we had a point P on the terminal side of an angle. It's somewhere on the terminal side of an angle. I don't care exactly where. The important thing is that if it's in the second quadrant, the x coordinate is negative and the y coordinate is positive. R, of course, is positive. R is also positive. X is negative, y is positive, r is positive. Let's see which trig functions here are positive. Y and r are both positive, so sine theta is positive. X is negative, r is positive, so cosine is negative. X is negative, y is positive, so tangent is negative. And the reciprocals of the negatives are still negative. The reciprocal of the positive one is positive. So in the second quadrant, sine, which is y over r, sine theta, which is y over r, is positive, and so is its reciprocal. Okay, so sine and its reciprocal are positive. Its reciprocal, of course, is cosecant. Sine and its reciprocal, cosecant, are positive. In the third quadrant, let's look at a point in the third quadrant. If the angle's in the third quadrant, its terminal side is in the third quadrant, the point in the terminal side is in the third quadrant, x must be negative and y must be negative, or it wouldn't be in the third quadrant. But r is still positive. Since y is negative and r is positive, sine is negative. Since x is negative and r is positive, cosine is negative. But since x and y are both negative, tangent is positive. So in the third quadrant, tangent and its reciprocal, cotangent, are positive. Tangent and cotangent are positive. Tangent and its reciprocal. Finally, a fourth quadrant angle, the point on the terminal side would have to have x positive and y negative, or it wouldn't be in the fourth quadrant. X is positive, y is negative, r is, of course, still positive. X is positive and r is positive, so cosine is positive, but y is negative, so sine comes out negative. And x is positive and y is negative, tangent comes out negative. Only cosine and naturally its reciprocal, secant, are positive in the fourth quadrant. Cosine and secant are positive. So, in the first quadrant, all trig functions are positive. In the second, sine and its reciprocal. In the third, tangent and its reciprocal. And in the fourth, cosine and its reciprocal. There are mnemonics, simple ways of remembering this. Let me just redraw this without all the other stuff. Very often we just put this down like this. ASTC. To mean that all trig functions are positive in the first quadrant. The sine and its reciprocal, which is cosecant, are positive here. The tangent and its reciprocal cotangent are positive in the third quadrant. Cosine and its reciprocal secant are positive here. Okay? You could say all students take calculus, or Albany State Teachers College, or whatever mnemonic. I only give you nice mnemonics. If you have some obscene mnemonics you want to use, go right ahead. But what we have here is ASTC to represent which trig functions are positive, okay, in the given quadrants. Now, on the board, we have all the information we need to figure out the trig functions of second, third, and fourth quadrant angles. Okay, let's see where we have it. We were down to this point. It can be proven that the trig function of a second, third, or fourth quadrant angle is equal to plus or minus the same trig function of the corresponding acute reference angle, where the plus or minus sign is determined by the quadrant in which the angle lies and the trig function in question. According to, let's add this in. And I'll just make this little picture and you'll know what I mean. According to this ASTC business, all students take calculus. Let's work out some examples, and you'll see that it's a very straightforward procedure. I'm going to be working with the basic angles, the ones whose trig functions we supposedly know. I discussed them in an earlier tape. But of course, it would be equally applicable if you needed to look in a table. For example, if I was working with 37 degrees, I would look in a table to figure out its sine. Rather than 30 degrees, I know the sine, for example, is 1/2. Okay, let's start with the sine of 150 degrees. This is the first one I want to figure out. Okay, even if you had a table, as I said, the tables only go from 0 to 90 degrees, so we need to know something in order to work this out. The first thing you do is you say to yourself, 150 degrees lies in the second quadrant. Okay? Let's go over here. We're talking about an angle between 90 and 180 degrees. That is a second quadrant angle. According to our chart, if theta is in the second quadrant, it's 150 degrees between 90 and 180, we will work instead with the acute reference angle, 180 degrees minus theta, 180 degrees minus 150 degrees, or 30 degrees. This is our basic angle to work with. Instead of worrying about the sine of 150 degrees, since it's in the second quadrant, we subtract the angle from 180 degrees and we get 30 degrees. So it's going to be plus or minus the sine of 30 degrees. This is where we are now. In other words, instead of worrying about the sine of 150 degrees, we're going to reduce it to plus or minus the same trig function, still sine, of the corresponding acute reference angle. Now what we have to do is figure out whether it should be a plus or a minus sign. Okay, and I said over here that it's determined by two things: the quadrant in which the original angle lies and the trig function in question. Okay. We are talking about a second quadrant angle, and we're interested in the sine. If we look at our chart, in the second quadrant, sine is positive. So therefore, we can replace this question mark by a plus sign. It'll be plus the sine of 30 degrees, because sine was positive in the second quadrant. All trig functions positive in the first, sine and its reciprocal positive in the second, tangent and its reciprocal positive in the third, cosine and its reciprocal positive in the fourth. So it becomes plus the sine of 30 degrees, but since we know the sine of 30 degrees is 1/2, we now know that the sine of 150 degrees is also 1/2. Let's try another example. The cosine of 2/3 pi. Okay? There is nothing wrong with the radian measure of an angle. I find that, though, from what I've given you, it's easier if you would first turn it into degrees. Okay, so to change this into degree measure, we'd have to multiply by 180 degrees over pi. And this becomes then the cosine of, the pi's cancel, 3 into 180 degrees goes 60 degrees times 2, 120 degrees. So we're talking about the cosine of 120 degrees. First thing we notice is that this is a second quadrant angle. The first thing we get, okay, after we know it's a second quadrant angle, we then have to get the corresponding acute reference angle. Once again, in the second quadrant, you subtract the angle from 180 degrees. Okay, for an angle between 90 and 180 degrees, and the angle we're dealing with is 120 degrees, we subtract 120 degrees from 180 degrees. And we get that this is going to be plus or minus the cosine of 60 degrees. The corresponding acute reference angle to use is 60 degrees. 180 degrees minus 120 degrees. Now we have to figure out the plus or minus sign. Two things determine it, the trig function and the quadrant. We're talking about cosine in quadrant 2. But we look over here and we say, in the second quadrant, only sine and its reciprocal are positive, sine and cosecant. Cosine is not positive, it is negative in the second quadrant. So, the answer, naturally, the cosine of 120 degrees should be negative. It comes out negative the cosine of 60 degrees, which is negative. Now, the cosine of 60 degrees is the same as the sine of 30 degrees, because the cosine of an angle is equal to the sine of its complement. And we get minus 1/2 as an answer. Okay, let's now work with the sine of 225 degrees. We are talking now about an angle in quadrant 3. Okay, we need to get the corresponding acute reference angle. It's going to be plus or minus, we'll have to figure that out, the sine of the corresponding acute reference angle. Now, let's go back over here. In the third quadrant, between 180 degrees and 270 degrees, and 225 degrees certainly falls in that category, we take 180 degrees away from the angle. See, here in the second quadrant, we subtracted the angle from 180 degrees. But now we take 180 degrees away from the angle. It's 225 degrees minus 180 degrees, which gives us 45 degrees. It's going to be plus or minus the sine of 45 degrees. Okay, but we're interested in sine of a third quadrant angle. Now, sine is positive in the first and second quadrants, but it's negative in the third. Only tangent and cotangent are positive in the third. So it's going to be negative the sine of 45 degrees, which is negative. Now, the sine of 45 degrees, we know from the last videotape, is the square root of 2 over 2. Okay, if this had been, say, 220 degrees, we would still subtract the 180 degrees from it. We would get negative the sine of 40 degrees, and that we'd have to look up in a table or use a calculator. Okay, but as I mentioned, the tables themselves only go from 0 to 90 degrees. So you do need this information. Let's try now the cosine of 330 degrees. The first thing we notice is that this is a fourth quadrant angle. Let's look at how we get the reference angle. In the fourth quadrant, from 270 degrees to 360 degrees, and 330 degrees lies in that interval, we subtract the angle from 360 degrees. So it's 360 degrees minus 330 degrees. We're working with 330 degrees here. 360 degrees minus 330 degrees, which leaves us with 30 degrees. So it's going to be plus or minus the cosine of 30 degrees. All right, now we've got to figure out the sine, the SIGN sine, okay? Cosine in the fourth quadrant. Cosine in the fourth quadrant happens to be positive. So it's going to be plus the cosine of 30 degrees, which comes out plus, now, the cosine of 30 degrees is the square root of 3 over 2. So we get plus the square root of 3 over 2. And let's try one more example on this tape. The tangent of 315 degrees. Once again, we are in the fourth quadrant. So we subtract the angle from 360 degrees. 360 degrees minus 315 degrees gives you 45 degrees. That is the acute reference angle to use. It's going to be plus or minus the tangent of 45 degrees. Now what we have to do is figure out what sign should tangent of a fourth quadrant angle have. Well, in the fourth quadrant, only cosine and secant are positive. Tangent is negative, so it's going to be negative the tangent of 45 degrees. Negative, now the tangent of 45 degrees, that's a basic angle. The tangent of 45 degrees is 1. Or you could figure it out by the sine of 45 degrees over the cosine of 45 degrees. Either way, we get 1 for the tangent of 45 degrees, and the final answer is negative 1 for the tangent of 315 degrees. And that brings us to the end of the tape.